Ladies and gentlemen, welcome to today's tutorial. We are going to look at how to use the Excel package to model a graph. So generally when we get data from experimental sources, we are always faced with difficulties in treating them using Excel. So this video will help us to overcome that challenge. So once you have your data, you are supposed to input it in Excel, and by default Excel recognizes the first column of data to be associated to the x-axis or the abscissa, while the second column of data comes to the y-axis or the ordinate. So for this example, we are going to use random numbers as such. So the first thing will be for us to label our columns. So we have the x column, which means for the x-axis, and the y for the y values. So I said by default Excel recognizes the first column for the x-axis and the second column for the y-axis. So I'm just using random values for this example. So I input random values from 0 to 7, and for the y values I input also random values. Oh, let's see, good, and the 14. Once this is done, we are supposed to ask Excel now to plot this. That is the first step. Ask Excel to plot this on the coordinate system. So we have to select all the numbers, only the numbers. Once the numbers are selected, we go to insert. Once in insert, we go to random point. We choose random point, and we choose the coordinate without a line. So we have this. I'm just going to make it a little bit bigger so that we can see better. Okay, so once this is done, I will be expected to have the title of my axis, both the y and the x. So I'll just come to this plus here, click on it, and I choose title of axis. So once this appears, I will double click on it, then I will delete the things there, and maybe my y axis was denoting distance, so I'll just write the distance. If I am supposing my y axis was distance, I will write the distance, which means I could equally write here in bracket distance, and here to be set distance. And if my x-axis on its path indicated time, I will just put the time, and I can put here now in bracket my time axis. So once this is done, the next thing I will need to ask Excel now to locate what we call the best straight line, because with the nature of these points, I don't know which point is the best. So I'll need to ask Excel to help me locate the best straight line. For me to do that, the first thing is to click on the plotted values, and my plus sign here will show. Then I will click on the plus sign again, and I'll come here. I have tendency curve. I click on the tendency curve. Once I click on the tendency curve, I will see that it looks like this with dots on it, but then it is not good enough, because it is supposed to appear with a line, not dots. So I'll come now to the shape style below the plus. I'll come to that style, the second box. I'll click on it. Once I click on it, I'll be able to choose now that it should give me a straight line. So once it gives me that straight line, the next thing will be for me to locate a better color. The blue seems not the best, so I'll scroll like this and locate black. Okay, once this is done, I now have my straight line, which is the best straight line. So after having the best straight line, we are sometimes asked to either determine the gradient of the straight line, or we get the intercept of the straight line. In order to do so, there are two ways that we have to do so. The first method constitutes of coming to this, of using this graph directly. So you come to any of these plotted points, locate your mouse on the plotted point. Once on the plotted point, the mouse will indicate the coordinate. So if you move around until you are able to see, for example, here I'm on series 1.6 with coordinate 612. It means I'm on a particular point. So I right click on that point. Once I right click on that point, I will have add a tendency curve. Okay, so we will come there. So once that is done, we will scroll now down. We will scroll now down like this, and we will see somewhere here show equation on graph. We check it. Good. Once you check that, you can now close this box. So when you check that, you realize that this is the equation. Let's zoom it a little. Let's zoom that equation a little so that we can see it better. Okay, let me put it like that. Good. Let me just position it there like that so that we can see it here as y is equal to 1.86x plus 0.33 as the intercept. So it means that at this junction I can conclude that the gradient of my straight line is 1.669 and the intercept on the y-axis is 0.33. So this is done by asking Excel to automatically determine the values for you. Now some of us may not want to do it that way. You may therefore just want to do by calculation. So for you to go by the method of calculation, you are going to type. The first thing, you press equal to and you press slope, all in capital letters. Slope, you write slope, S-L-O-P. Now my keyboard is, my Excel is in French. I'm therefore using pente, la pente, which means slope in English. So pente. Once I type pente, you see it comes here. So I'm supposed to select now the y element followed by a comma and the x element. So I'll select the y element followed by a comma. I will now select the x element and I will close my bracket and I'll press enter. So once this is done, this is here 1.86904 and so on and so forth. So you could choose to reduce the number here. You might just want to reduce the number of decimal places so that you have the same like the other one. So you see that by calculation we have the same value as the one determined by the graph. So these are the two methods we can generally use to calculate our gradients. So I'll be hoping to see you in the next videos. Don't forget to like, comment and subscribe, and most importantly share with your friends so that they can also benefit from their advice.